Hello guys, Abhika Swagat hai. This is Jose. Welcome back to our channel. So guys, in this video, basically we are going to see the some problem, competitive problem like recursive digit sum, which we can also call it as super digit sum. So we have 2 to 3 ways of doing this problem. So we'll try to explain this problem in 2 to 3 ways, which is the order of n times, order of n time complexity, and also order of one time complexity. So let's see now.
Hello, this is Surya Teja. As Shiva told, we are now going to discuss recursive digit sum problem. First, I will explain the question and then we will go to solution. First, what is super digit? A number which is given is divided into its digits and then we are going to sum them all up. Then we will get a number. We call it a super digit if the resulted sum has only one digit in it. Otherwise, what we are going to do is we will recursively sum their individual digits until we will get at last a single digit only. I will show you it in Paint. Let's say we have a number 576. Then the sum of digits will be equal to 5 plus 7 plus 6, which is nothing but 18. As you can see that 18 is not a single digit number. So what we are going to do is next we will sum the individual digits of 18, which are 1 and 8, which will be equals to 9. As you can see that 9 is a single digit number. As you can see that 9 is a single digit number. So it is the super digit of our actual number 576. Let's come again to hacker rank problem. Here what he have given is k. He have given the value n. He have given the variable n as well as k. K is nothing but the
So basically, the k here is nothing but, so for example, there is a 9875, right? So we need to take k times. K times is nothing but, suppose there is a 576 as Surya explained. So 576, so k equals to 4, right? So there will be 576, 576, 576, 576, 4 times of 576. Can you write Surya there then?
okay. I am going to explain that as well. If n is 576 and then k is 3, then then we have to calculate sum for sum of 576, 576, 576 3 times.
Which means the k times of number n digit, n variable, which we can also call it as n variable. We need to calculate the sum of 3 times of 576. Suppose, as we have seen here, 5 plus 7 plus 6 is 18, right? So we need to find 3 times of 18, which means 3 times of 576, sum of digits of 576. We can also write it as sum of single digit, sum of single time, sorry, sum of not single digit, sum of single time, which means 5 plus 7 plus 6 is 18, right? Which is single time. So suppose k equals to 3. So then 18 into 3. So 18 into 3 means which is about 74, 24, right? 54, yeah, 54. So 54 is not a single digit, right? So we need to do again sum of digits. So then it will be 5 plus 4, which means 9. So 9 is single digit, right? So the final answer should be 9. So for this problem, we are trying to provide the solutions in different ways. So as Surya explained the problem statement, I will be discussing about the code in different ways. So I will try to explain you in the basic way for now. So we will try to see in another ways as well. So we here came to the editor, right? So basically I will explain in the format of basic format. So as Surya taken as example 576 as n value and k equals to 3, right? So here I will write, suppose we need to recursive of n by 10 times, right? Because suppose we got the 29 as a value, right? So we need to recursive until it get the single digit, right? So I will write it as suppose so first we will write for the sum of digits itself. Okay, for sum of digits n should be not equals to 0, right? As you know, so I was getting the remainder equals to n percentile 10. So n percentile 10 gives here the which gives the last digit of number. N percentile 10 gives the, suppose there is a 576, right? So it will give 576, right? So it will give 6. So we will get the remainder as 6, right? So I need to sum all digits. So I will write it as sum plus equals to, which means sum equals to sum plus. So here I haven't declared the sum. So I will declare the sum here as sum equals to 0. Okay. Then every time we loop over each digit, we need to sum the each digit in a number. Each digit is nothing but 5 is the digit, 7 is the digit. We need to sum all of them. Okay. So here we are doing adding the last digit to adding last digit to sum. Okay. So then we'll do num equals to sorry n equals to n by 10. So basically, so suppose if we do 576 divided by 10, it should be like 57.6. As we know, n is integer, so it will take it as 57, right? So in first iteration, it will be 57. Okay. Then when it comes to 57, 57 not equals to 0, right? Then 57 percentile 10. Then it should give 57 percentile 10 will remainder 7, right? So sum equals to sum plus. Already in sum 0 plus last remainder, which means in sum we have, okay, I will write here. So in sum we have first of all 0. After that, after adding last remainder, it is 6. Sum equals to 6 after adding last remainder, remainder in last iteration. Okay. So now the remainder will be 57 percentile 10, which is 7. So we will add sum equals to 7 plus 6, right? 7 plus is nothing but 13. Okay. Then we will again following the this we will again calculating the n by 2, which means 57 by 2, sorry, 57 by 10, so which is 5.7. As we know, integer does not take any points, so it will taken as 5. So 5 not equal to 0, as we know, right? So then 5 percentile 10, the solution will be 5, right? The remainder will be 5. Then we will adding 13 plus 5, adding to the sum. So it will be 18, right? 18. Sum will be 18. Here the total sum will be 18, right? So then n equals to n by 10. We will again iterating and we will again calculating n by 10. So 5 by 10, which means 0.2, and in integer it will take it as 0, right? So 0 not equals to 0. No, the condition fails. So we will print sum, system dot out dot print ln. So sum, right? So I will do this to comment section and I will run this program. It should output as, okay, sorry, I have,
Reminder declare చేయలేదు.
okay, I haven't declared the reminder. Yeah, so I think it will work. Yeah, so it is giving the value as 18. As we have seen, if it is double digit, we need to sum again. So for this one, we can write it as, suppose I will take another for loop for this one, another while loop. Okay, so let's take while, so which will checks for the n by 10 not equals to 0, which means suppose here it is a 18, right? So it will check for the 18. So it will check for the 18.
Okay.
It will be checked for the 18. Okay, 18 by 10, which means 1, right? Sorry, 1.8, right? So then it will be, how much it will be? It will be like 1. The num will be 1. So I will do here as n equals to sum. So n by 10 is 18 by 10, right? So 18 by 10 means 1.8. In integer, we will call it as 1. So 1 not equals to 0. Again, it will come to the this while loop, and again it will start. So as I declared n equals to sum, so the first iteration n is 576, right? In second iteration, we are assigning some value to the n value, which means the will be n will be n will be 18. So if I print here, so I will do one thing. I will print n for every iteration. Okay. So suppose first iteration it will be 576. So for first iteration the result will be 18. Then it will check for the 18. 18 by 10 is 1.8, which is not equals to 0. So it will goes to here the 18 not equals to 0, right? So 18 not equals to 0. Then if you take 18 percentile 10, 18 percentile 10 is 8, right? So we will add sum to the, instead of writing sum here, we will do we will initialize, we will declare sum inside the while loop, because we are dynamically changing the sum, right? So I will do like sum equals to 0 here itself. So instead of declaring here, I'll declare here. Okay. So next time the sum will be 0, right? So n value is 18. So for first iteration, the remainder is 8. Remainder is 8. So sum is 0. 0 plus 8, which means 0 plus 8, the sum will be 8, right? Sum is 8. Okay. Then n equals to n by 10, which means n is 18 by 10, which is 1.8, such that so it is integer, it will take it as 1, right? So n will be 1. So again it will loop, which means it will again come to this condition, 1 not equals to 0, right? So it will comes to 1 percentile 10, which means 1 percentile 10, which means 1. So the sum is already 8. So sum equals to sum plus remainder, which means remainder now it has for now remainder value is 1, right? So 8 plus 1, so which means 9. Okay. So sum value will be 9, right? So n is n by 10, which means 1 by 10 is equals to 0.1. In integer, we will take it as 1, sorry, 0. So 0 not equals to 0, then it will be then it will come out of the loop. The sum value is 9, right? So n equals to sum, it will assign n equals to 9, right? So next it will again iterate and check n by 10 times, sorry, n by 10. n, here we assign some value to the n, right? Some value to the n. So n by 10, which means 9 by 10, which will give 0.9. In integer, we will take it as 0. So 0 not equals 0, the condition fails. So it will print the sum. Okay. So if I run this code, it should give like 9 answer. I think, okay, I haven't given here any. Okay, we will print here it as n. So we can see in first iteration the sum is 18. In second iteration the sum is 9. In third iteration, sorry, in second iteration it is 9, right? So I was printing the final answer here. Suppose if I like here, if I give it as iteration, so for first iteration it is 18, second iteration 9. So 9 is a single digit. So coming out of the loop, then it will printing the final value. Suppose here what we have here, it is a 9875, right? So I will take 9875 and k value is 4, right? So we should get the value as 8. Okay. So if I run, so after getting a solution, it is giving us 2, right? So we'll check. Okay, here it is giving 8. So what I have done, okay, I haven't taken the k value as 4. So suppose it is 9875, right? 9875. So 9875, which is multiple times, which is the 4 times. Instead of doing sum 4 times, I will do it as only 1 time and I will multiply with k first for the first time. Okay. Suppose 9875. So the sum will be 29, right? So I will multiply with k times, and so 29 into k, which is 116, right? So I will multiply with k times sum for the first time for the first time itself. After that, so I was writing as sum star k for the first time, and then I will assign k equals to 1. So from the next time it will multiply with the 1. So it will not affect the remaining recursion, I mean remaining traversing. So remaining looping, we can also call it as. So next time it will be 116, and so we will assign k equals to 1, right? So then it will be 116. So the sum of 116 is 8. So 8 star 1, which we can also say it as 8. So 8 is a single digit number, so it will return the 8. So suppose if I run it, so whether it is giving right solution or not, let's see. Okay, I haven't mentioned comments here. Yeah. So the answer is giving 8. So as we have seen here, the first one is 116, next is 8, and next is 8, right? So basically we are we are calculating the sum of the digit and multiplying with the k times. Okay. So once we have multiplied with the k times, we are assigning k as 1. Then we are again finding the sum of digits until the sum of digits is single digit. Okay. So in first iteration is 116, and in second iteration is 8. So 8 is a single digit. It is giving it as 8. So let's see for the another solution as well, which is 148. The k value is 3, right? Yeah, 3. So 3, it should be 3 answer. Okay. Yeah, it is 3. So let's see the solution. So for the 148, the sum is 148. Then 148 is 13. So k is 3 times. Then which means 39. If we sum 39, it will give 3 plus 9, which is 12. So 12 is double digit. So again I was summing up the digits. So 1 plus 2, which is 3. So the single digit is 3, right? The digit we got 3 as single digit. So the final answer will be 3. This is how exactly the program works. So we have seen the some order of n or order of n square way, right? So we will try to figure out how it will be. So it is basically order of n square, we can say, or order of n. So we will try to figure out in the order of n way with recursive algorithms, like with recursive way. So it will be explained by Surya. He will explain you as simple as. Okay, Surya, take you.
Okay, as Shiva said that Shiva said he explained the program and wrote it in iterative manner. Now let's do it in recursive way. Okay, this is the recursive way. It's second way to solve the problem. What we are essentially doing is we are iterating outer while loop multiple times, so we can make it into a recursive version. I will show you that. In order to do it recursion, first we need to take n k, and then we are declaring a function, a recursive function, which would be static and which returns int, and the name of the function is recursion. Name of the function is recursion, which takes two integers n as well as k. These n and k variables are the same variables that we have declared inside this main function. Here at first n will be 148 and k will be 3, which are given to, I will delete this lines. Those n and k values are given to the function which we are going to write now. Here what we will get is n value means 148, and here we get k value which is 1, which is 3. Initially sum will be 0, and we will find sum of those digits of n and we will multiply with k, and then we will store the resultant sum in the n. Next what we have to do is we have to return the value of recursion of these new n and k variables, which are nothing but this n is nothing but sum into k and k is 1. So I am calling again n comma k function. This is the recursive code, but we have to have a stopping condition in order to stop the recursion. What would be our stopping condition is the same as this condition which we have written in while, which is nothing but n by 10 not equal to 10, not equal to 0, n by 10 not equal to 0. In that case what we are going to return is n. For 148 and k equal to 3, we have to get value. What is the value we will get? Let's run and see.
Surya, I think like you haven't declared the reminder.
Okay, I haven't declared reminder variable. Int rem array. Okay, int rem is equal to 0. Sum I have initialized. Okay, right. It's showing all 48.
And the
Okay, it
condition
will
will
be
be
equal to,
f of t equals to 0. So
okay,
we
it
have
will be equal to 0. Okay, we are getting the final sum as 3, which is correct answer.
Surya, can you check for the 9875 as well? 9875 and k equals to 4.
Okay, I will do that as well. 9875 and k equal to
4.
4.
Yeah. Yeah.
Okay, it's coming as 8. That's the answer we have got earlier also. For 9875 k equal to 4, our super digit is 8. We got that as well. I want to tell you that we have written the condition n by 10 equal to 0, but here in the iterative version we have kept it as n by 10 not equal to 0, because we are iterating when n by 10 not equal to 0. After several times when n equal to 0, n by 10 equal to 0, we are exiting the loop. So what we are essentially doing here also is, when n by 10 equal to 0, then we are exiting the recursion by returning the n. That is the reason we have here kept n by 10 equal to 0 and not n by 10 not equal to 0. This is the second way to perform the iteration.
Okay, Surya. I think the recursive way is very good, right? So, like,
Okay.
like I love challenges, right? So, can you give me some challenge in this problem?
Okay, we have done both in you have done in iterative way and I have done it in a recursive way, but our time complexities of solving this problem would be, of course, the order of n square. Can you do it in less time so that we can save some resource?
Okay. I think, yeah, we can do maybe.
Okay, then show me. I'm
Yeah,
curious about it.
yeah, I will share my screen right here. You can
Okay.
stop. I hope my screen is visible, right? Yeah.
Yes, it is.
So, yeah, your code is this, right? So you have used the whole recursion and everything, right? The everything recursion, and which is order of n square. So let's do one thing. So why can't we do in order of one time? I think we can. So I will remove this whole function here. Uh, I will write. So we'll do one thing like, yeah. So there is a n and k, right? So the inputs are n and k, right? So we'll do. So we can get the sum of digits by multiplying with the n. The remainder is nothing but the sum of digits. Suppose if I say, for example, uh, there is 18, right? For 18, let's take 17. Okay, let's take 17. Okay, 1 plus 7, it is 8. 8, sorry. So 8 percentile 9. Oh, sorry, which is 8, right? So which is 8. Suppose 17 percentile 9 is also 8, right? Is also 8, right? Suppose let's take 19 percentile 9, which is 1. Yeah. So 19, right? So 1 plus 9, which is 10. Then 1 plus 0, which is 1. So the answer is same. So basically, here the main problem or main issue is that, so we can do with order of n. So basically, we should uh, divide by 9, then the remainder will be our sum of digits of that number. Suppose let's take 9875. So I will try to print n percentile 9. If I print n percentile 9, it should give 29, I think, not 29. Give me a minute. There is some issue. Yeah. What is okay. Yeah. Basically, the n percentile 9 is 2. So why it is giving is 2. So 9875, which is about 29, right? 8, 9, 8, 17, 17 plus 7 plus 7, which is 24, 29, right? So 29, which means 2 plus 9 is 11, right? So 1 plus 1, which is 2. So hope you got the solution, right? Suppose if we want the sum of digits until it became a single digit, okay, so we can do by dividing with the 9, the remainder will be the sum of digits until it become a single digit. Okay, so as we have k equals to 4, so we need to do in the 4 times. So if I write n star k percentile 9, it should be 8. Okay, I haven't given any comments here. So 8. The answer is here is 8, right? So it is some type of formula. So basically, I have studied from this some link here. I will share this link in the description itself. Go through this. You can get the whole solution and the generalization also they have mentioned here. Okay. So it gives the solutions like the digit sum of a number to the base 10 is equals to its remainder upon divisible by 9. So this is the condition I was taking here. I was implementing this condition here. So I'm trying to do the problem in order of one way, order of one time complexity way. So suppose if I give 9 and if I give it is 1, so what it should be? It should be 9, right? It is giving as 0. Why it is giving as 0? Because 9 percentile 9, which is 0, right? So we should get it as 9. So it is missing this corner case, like right 9, which is missing with 9. So suppose if I give it as 0, it should also return 0, right? Okay. The n is 0, it should return 0. Yeah, it's working for 0. So I need to do for the 9. For the 9, it was not working. So I will do one thing right here. If n equals to 9, okay, or if n star k percentile 9 equals to 9, sorry, yeah, if it is 0, then it should print 9, else it should print. So for 0, it will fail again, right? So for 0, it will fail. So I will try to do like this. Else if I will write condition for the if, like if n equals to 0, then it should return 0, right? So we will return 0. It should work for every corner case. Suppose if it is n equals to 0, it will return 0. If n equals to 9, it will return 9. Yeah. Suppose as question is there, if we take 148 and 3, 148 and k equals to 3, it will work it as, so the answer is 3. The answer is 3. So basically it is the order of one way. We are not iterating, we are not recursing the problem. Like we are trying to decrease the time. Okay. We are trying to decrease the time. So I found this in some internet. So you can also use this link and try to understand the whole thing, what exactly going on inside this formula. Hope this will help you when it comes to interviews. Most of the questions I have faced this type of questions, which is recursive and everything. So they asked me like the order of it is order of N-square. Can you write in order of one, like that? So in recent interview, like I figured out uh, this condition. So hope it helps you, I think. So guys, like this is for this video. So in next video, we will try to come with another solution as like this. So we will try to solve the problems which is supposed the most of the problems will be order of n square, like that. We'll try to decrease the time complexity. We'll try. So for every solution, we'll come with another solution in next video. And don't forget to like, share, and subscribe. Please share with your friends. It helps a lot for them and for us as well. And don't forget to subscribe. मिलते हैं next video में. Bye bye.